Okay, this week, new products.
Okay, we have a lot of new products, but we have a little bit of time, so I'm going to get to everything. Turn off, we have this extremely useful for all sorts of things. Mono 3.5 millimeter audio jack, and we also have the plug. 2 alligator clips where the tip is the white alligator and black is the ring. So this is good for all sorts of stuff. One, it's good if you have something like a microbit and you want to connect it to audio, because it like in a lot of projects you don't have a speaker built in, but you want to connect it to headphones. But it's also really good for accessibility tech. So AT switches all use 3.5 millimeter audio jacks. And this way in the mono, because it's like one, the sleeve is the ground and the switch is the tip. So this way you can quickly get things together. So I'll show these off.
Okay, do you want me to show the other one?
Yeah, show both, because they're kind of a set.
So,
and they're nice molded. It took me a while to get these with like the nice molding.
So you can go either or this way. Like, so here you go.
Both.
Well, there you go.
One way or the other. All right, so let's look at them on the overhead and I can show you,
want that one.
how you use them.
How do you use these?
So let's say you have a microbit and you want to connect to the audio on pin 1. You connect black to ground, or you can do it like this way. And then you can connect the tip to this, and then you just have whatever headphones you want, connect this, and because it's a mono connector inside, it'll automatically connect left and right together, so you'll get audio out of, actually sorry, this one, sorry, you'll only get audio out of the left ear because it's mono, but that's okay. And then if you connect this to a stereo system, likewise, you'll get one channel. And if you want to plug it into, if you want to like read audio data in, if you have like analog digital converter, you can do the same either way. You can either use the plug or the jack. And if you're doing accessibility tech and you want to mimic an AT switch, you would use this as the connector, and then these connect to whatever gets contacted together. And if you want to connect to an AT switch, you can plug it into here and then read this from a microcontroller or whatever you want to have activated by the AT switch. So it's a set. You get either one, choose which one you want, choose wisely. And if these become popular and people like them, maybe I'll get a stereo set as well that has 3 cables. But for most people's uses, for audio or AT, I think mono is good.
All right, next up.
We have some USB-C to C cables. We had C and micro:Bit for people who had Mac laptops, but as more products come out, we're seeing a lot of products that have USB-C built into them, including the M5 stack we'll show shortly. So we have 2 cables. We have a 1 meter long and a 6-inch long USB-C 3.1 cable with all the wires connected and an E-mark chip. So these, it's a little expensive. They're like wondering like, why are these cables so much more expensive than normal USB cables? Well, first, these can do like up to 5 amps. They're meant for very high current. They have all the wires connected, so it's not just USB data, in the 4 USB data pins. It actually has all of the pins connected. So you can use it for very high speed connections or high power connections. You can use this to charge devices, switches, laptops. And yeah, it has USB-C on both ends, and they're reversible, so no matter which way you put it, it'll work. It's a nice thick cable. It's got, I think, it's up to 30 volts, because it says, up to the highest voltage. And it's got they're supposed to be, when you get USB-C cables, they're supposed to have this chip inside that helps do the power negotiation. A lot of lower cost cables leave that out, but these have that chip in. So if you're reading something and it's like, oh, don't make sure to get, for this laptop or device, you need an E-mark cable. These cables have the E-mark in them. So we have this long version, and then let me see if I have the short version. We also have, because I have all these cables here because I was connecting stuff to stuff. I may not have it. But we have also in the shop a 6-inch long version of the same cable. I'll find it in like exactly 3 seconds. That's how it goes.
Well,
oh, wait, here it is.
Oh.
Yeah.
Right.
It's short. That's why it's so hard to find. But it's a shorty version. So 1 meter long and then 6 to 8 inches long.
Yep.
2 cables.
All right. Speaking of USB.
USB-C is on the menu. So now you're like, okay, well, I have USB-C stuff, but how do I know that it's actually charging at the right rate and voltage? Because with USB, A and B, you know, you were 5 volts and you had up to, you know, 500 milliamps max, maybe 1 amp max. And like, you know, if you're using a Raspberry Pi, you could push up to 2. But once you're trying to get past 2 amps, actually the USB cables aren't really, they don't have enough conductors to pass so much current. You're not going to get, you know, because you have like 4 times as many conductors for power and ground on the USB-C. So we have this handy little tester. It's a little pricey, but it's really nice because it does USB-C or USB-A and every combo thereof. So let's show a demo of this. So I have this connected up. This is just going to be for plain USB because I don't have my USB-C power adapter here. But you plug into USB and it'll show, let me put it on the big display. It'll show the voltage and current on here. So right now it's 5 volts, no current. And then let's say I have my M5 stack and I want to plug it in. So I can plug it like this, and you'll see it's charging up. It dropped down to 4.64 volts and 0.4 amps.
This is handy.
And then what's nice is that it also acts as an adapter of sorts because this has USB-C. You plug it in, and oh, sorry, this actually goes the other direction. It's charging, but actually the current measurement doesn't realize it because it's thinking that it goes the other direction. But I can also convert this to USB-C here. I think it goes this way. So plug it in like this, and yeah, now the current is correct because it's positive, and it's drawing about ½ an amp over USB-C. So good if you want to like do adapting because it can do USB. You know, it's got the USB 3 connectors to see in out all different ways, and then you can select different modes. Like it can. It's a little dim, hard to read, but it can show you the D plus and D minus voltages. It can calculate total current. It can calculate the impedance. You can have alerts that tell you if the voltage goes above or below certain settings. But I actually kind of just like this basic setup where it just tells you the voltage and current. But for when I've been testing these, because a lot of the USB testers don't do over 5 volts because they're meant for USB-A. They don't do 30 volts. This can do up to 5 amps and 30 volts. So it's perfect for, you know, when I was getting all these cables and I was testing them with laptops and switches, and I have a USB soldering iron, the only way to be able to measure the high voltage and current is with these kinds of high quality cables and a high quality thing.
Yeah, one suggestion just for all of us out there, get one really good USB-C cable because everything's going to break and fail, and it could just be the cable. So
yeah, you had your laptop on. You were like, why isn't my laptop working? But it's actually the cable.
Yeah, you'll get some type of not so great USB-C to C cable in your life because they'll just start being part of things that just open up.
Yeah.
And you're going to think something's broken, and it may or may not have something to do with the cable. So even if you just get one, you know, put like a bright sticker on it or something, it's like, this is my, for sure, good cable that has everything.
Yeah, another thing is a lot of lower cost USB cables, they don't connect all of the contacts. They just connect the USB data plus and minus lines. They don't connect all the high speed lines. So if you want to use it for like displays or like, you know, HDMI over USB-C, you need to have one of the cables that, like, they're thicker because they have like 25 cable contacts inside.
Okay. Let's keep moving.
Moving right along. These are kind of neat. If you are watching Noah and Pedro's videos for 3D printing, you'll notice that they use these inserts a lot. And to get these inserts, they make assembling 3D prints a lot easier because of snap fitting or screwing directly onto them.
This video says it all.
Yeah, you use a soldering iron and you heat the tip up and then use it to push this brass insert in. And then after you remove the soldering tip, the plastic cools off and it grips onto the insert, and then you can screw into it without having to like worry about threading your plastic, which is like 3D printed plastic doesn't deal well with threaded threading. You know, if you try to screw directly into it, you can use plastic screws, but they never quite work. So these are nice because
we have a couple different types too.
We have 2 different types. We have one that's for 440 or M3, and that's this one. And this one, which is for M5, which has a bigger tip. And the reason, some people say, oh, you can use a soldering iron tip, but because they're conical, they end up gripping onto the insert, and the insert like pulls out. So these, because they're square and they have these little steps in them. After you do the insertion, when you remove the soldering iron, it doesn't snag, and so you get a very clean insert. Also, there's a nice flat step on it, so when you insert it, it goes in straight, basically. So they're a little bit more expensive than just using your soldering iron plain, but we recommend them. You can use any Hacko iron, including, there's one linked on the product page if you want, like what's the cheapest one you carry. I don't recommend using your nice iron. I mean, you could, there's no reason not to because you're not using your tips, but you probably want to have one that's just dedicated to plastic, because look at plastic on it and stuff.
Okay.
All right, we got some quick connects. These are JST SH. So you might be thinking, you know, you use JST PH a lot. These are SH. These are 1 millimeter pitch. These are used by SparkFun for their Qwiic connects, and they're handy, and we're going to make some stuff that's Qwiic compatible. So we thought, let's get these connectors in a 10-pack, mostly because I just needed them. And I'll show this on the overhead. Yeah,
and then one thing I should let folks know, we decided, let's support Qwiic, let's support Grove, and then we have Stemma and Stemma QT. So the way we've worked on things and made things is if you use Stemma, you can use all of them.
Yeah, Stemma is very, because it doesn't require any particular voltage. It has level shifting built in.
Yeah, we didn't want to have a whole other new standard, and we also wanted to support everything out there. So if you have Grove stuff, Qwiic stuff, you can use Stemma.
And this is nice because it's like this cable that we have, it just brings it out to blocks. You can just, terminals, you can just plug them into a breadboard. So this, of course, it's like hard to remove it because it's not soldered into something. But it's a very
someone in the chat had asked, how does it work with Grove? Well, we have...
Qwiic is not directly compatible with Grove. You have to be careful because
Qwiic and Grove don't.
Grove is 5 volts and Qwiic is 3 volts. So you just have to be careful. Just make sure that if you're using a device, it's not...
And what about Stemma? How does Stemma work with Grove?
Stemma is actually more like Grove, which is it provides 3 to 5 volts, but it accepts either one.
Okay.
We'll make a diagram at some point to explain
this. We will.
Because it is a little confusing. But yeah, so this cable is like a Qwiic cable using the JST SH, and this is the connector. It's a snug fit, but it's not too hard to, except if you get it in upside down, yeah. If you put it in the right way, it just fits in very snugly, and you get power, ground, and then 2 data lines, which they use for I2C data or clock. You don't have to use it for I2C. You can use this for anything, but if you want to match the Qwiic standard, then you should match the colors to the capabilities. And then just solder this in. You can solder it with an iron with a fine pitch tip, or if you're pick and placing, of course, it's not too bad either.
All right.
All right, we have...
This is exciting.
M5 stacks. Yay! This took a while to get, but we got them in. The M5 stacks are kind of neat because they are ESP32 dev boards, and they have a lot baked into them, and then they're kind of this plug-and-play modular system. So the M5 stack core, we have 2 cores. We have the gray core and the black core, and they're almost identical. Both of them have ESP32 module inside, so it's Wi-Fi, Bluetooth, ESP32, you know, the dual 240 megahertz core. Has an SD card slot, has a Grove connector, has a built-in micro battery, like 150 milliamps, very small. USB-C, and then a little speaker as well. 3 buttons in the front, and a 240 by 320 2.0 inch SPI display. And you can plug and play them with other modules. So I'll show this off. So this is the black one. Here you go. So it's got all these pins broken out here, so you can connect to them with plain header. And then here's the speaker. The speaker's here. I'll show that. There's 3 buttons, and this actually even has a demo. There's the SD card. There you go. SD card slot here. And I don't remember what this is. USB-C for data upload. There's a USB serial converter inside. Grove connector. Reset. So you can press this to reset the board. It does a little animation. It's backlight control, and you can see it does a little Adafruit GFX test. I was like, that looks familiar. That's good. I've written. And I don't know if this is easily removable. I guess it is. So the modules are stackable. This is the speaker, SD card slot, USB serial converter, some power stuff, ESP32 module, battery connector, I think, for optional battery. And then I think the little LiPo battery is in here, although I'm not 100% sure. I think it's underneath here. Anyways, there's a stackable header, 2 by 15 0.1 inch header that you can use to stack it onto other boards. So you can remove this bottom, and you see now that the battery isn't connected, because I think the battery was in here. There's also like magnets, so you can like magnetically connect to stuff. But this is like the core brains. And so we have 2 types. There's the black type and the gray type. And the black type is a little less expensive than the gray type. No, can you go back to?
Which one? This one?
Yeah, we have the gray type. So this one is gray. The gray type has an MPU 9250 in it, so it's a 9DOF motion sensor. Otherwise, the black and gray are the same. They're the same size, the same specs, other than the fact that one has this 9DOF motion sensor in it. So that's the core. Okay. The core, you just get the screen, the buttons. You get a lot. You have the screen, buttons, battery, USB cable, some header. You also got the computer kit, which I just thought was adorable. So this is, you plug the core into it. It comes with a core, and then you can plug in different little key control surfaces. So there's a calculator surface, there's a keyboard surface, and there's like a gaming surface. And it comes with MicroPython, so when you boot it, you can actually like start typing into it. Like this is actually the boot up demo. So if you want to go to the overhead, I can show this off. So this is, this is running MicroPython 1.92, and yeah, you can just type in directly from the keyboard. Of course, you can also connect over USB to upload data if you don't want to sit here and like type all your Python. And the way this works is that this is that core. This core is this part. So you see it just plugs in. And then this is the Faces kit. It has a bigger battery in it, as well as you can see the bigger battery. So of course you can run a lot longer because you want to run your computer for a couple hours. So there's this little keyboard kit, which has little tactile switches and little rubber bits. And then let me see if there's more faces that go along with it. There is. Where the other face went. So this plug-in version is the calculator. So you can see it has got numbers built into it. So if you want to make a little like your DIY graphic calculator, this one has fewer buttons, but they're labeled like a calculator or a phone. And finally, there's the gamer one. Again, not as many buttons, but they're in a kind of a gaming select start Game Boy style. And then they have this little converter that takes all the button switches and reads them in. So you can plug and play whichever you want and stack up, sensors and M5 stuff, and then you get to the GPIO still. So it's kind of like an all-in-one brick system. And then, yeah, it's got these little magnets to help you situate it. I think it feels like magnets. So whichever one you want, and then you can plug it in and make your own little computer. Very fun to build. Yay! And you can do MicroPython. So that's the M5 stack kit. So we'll get more M5 modules, but we want to start off with these nice basics. Next up, Reese's Pieces.
Yum.
These are little buttons. They're actually square top button caps. So if you have something with square, like I think 2.4 millimeter square top buttons, they plug in on top.
Something like this.
Like the PyGamer, which we wanted to have nice big buttons, so we went with the buttons that we pick and place are just square top, and then you pick whichever colors you want. So these are available, they're like $1, but then you can pick whichever color you like.
All right. That must mean we have some type of case for a PyGamer.
We also have a case for a PyGamer. This is an acrylic case with a bunch of pieces. You pull it apart, and I'll show, of course, the whole thing at once. And once assembled with the buttons, you get this fully put together PyGamer. Wow. Okay. And then we also have the PyGamer itself. So this is the fully assembled version. So you can see the case is a couple different pieces. You have 4 screws to put it together. They're nylon screws, and it holds the battery and speaker, as well as the PyGamer with all the slots that you need to access the stemma ports and the feather wings. And
so that's
SD
the case, and then what's inside of it is this.
Inside is the PyGamer, yay! So if you like the idea of the Pi badge, but you want to have a Pi badge that's very specific for gaming, it's very similar. It's a SAMD51, so it's running at 120 megahertz. It's got 512K of flash, 192K of RAM. It's got a 1.8-inch, 160 by 128 pixel screen, 4 buttons, and then a directional analog joystick. The analog joystick is really nice. It's more expensive than the badge, which only has buttons, but analog joystick, if you want to do diagonals, this lets you do that, and it has a really good feeling to it. You've got the NeoPixels in the front for dazzle display. It's a beautiful silk screen. On the back, you've got feather header, on-off switch. This has a stereo headphone jack, as well as a speaker output, and automatically, like when you plug in the headphones, it disconnects the speaker. LiPo battery and battery charging SD card to hold stuff, as well as 8 megabytes of onboard flash. It also has stemma connectors and feather header, so you can plug in whatever you like. If you want to add like Wi-Fi, you can plug that in. But it's designed for gaming. It's designed for MakeCode Arcade in specific, which is a really wonderful gaming system we've been having JP do a lot of videos for. I've been writing games in it. It's the easiest way to write games with drag and drop web interface, and you can download them onto your PyGamer. So for example, if you saw that video of the Sparky arcade and you're like, I want to play that game, here it is, live. And you can hear the beeps from the beeping in the speaker. And it has about 5 hours of runtime. I mean, it depends on how much you're bleeping the speaker, because it kind of takes a bunch of power. And if you're dimming the backlight, you'll get a couple more hours than that. And you can do all sorts of controls from within MakeCode. They take care of that for you. So you can write games, as easy as dragging and dropping a couple bricks. You can draw the sprites easily within MakeCode Arcade. Download them over USB, even over web USB, so it kind of one-click downloads. And we'll also have gaming ability in CircuitPython. And if you have gaming platforms for Arduino, such as Gamebuino or Arduboy, there's a compatibility library for them, so you can use the Pi badge or the PyGamer to run games from the Arduboy if you like. I mean, they'll be black and white and they'll be a little smaller because you won't get full color because they're black and white. Or in the Gamebuino, it'll actually be the same size because it uses the same size screen. And we also have a Nintendo emulator working for it, which I've shown off on the show and tell, and lots more. So if you're interested in gaming and you want something that's a simple, low-cost, portable game platform you can pick up, we have PyGamer. So this is since Fusebox, this is our first portable gaming platform, and I'm excited. I think the most important thing is that you can use MakeCode Arcade. Having a ready-to-go software platform for writing games easily is the hardest part of a gaming system, and MakeCode really did an amazing job.
Yep. And that was the star of the show tonight, besides you, Lady Ada, the community, and all the Adafruit helpers and more. So that was it.
Yay! Thanks, everybody.